through, sorry, whiteboard is where, whiteboard is this. So I want to say you that there are a number of points. I will try to use this correctly, but I have no writing pad, like, so I'm using, trying to create from mouse. Okay, so you have one category. Yes, this is dog. Okay, one. So it is one. This is no. Zero means no. Okay, and suppose this data is there. Yes. So these data points are, now if you draw a line like this or like this, or draw, if you are drawing parallel to this line, then it fit to this meet these points, this line meet all these points but not the lower points. If you are drawing like this, so how could you draw? Okay, what is the best solution? If you draw like this, something like this, if you try to draw like this, then it will be meeting all the points. Okay, meeting all the points means it will fit to your data. The learning will be according to the data given. So for that, in this case, you cannot draw a line. You cannot generally go and make a line to separate these things. Okay, your task is what? You either you have to say these points, these pics or these data is for dog, or these other points it is cat. Okay, not dog. So what you have to take? You have to draw like this. You have to make something, make your model trainable like this on the pattern of this. Okay. So if you are, able to make concept like this, then it will be what? It is logistic. It is logistic regression. Okay. So now, for again, I am trying to clear it. The similar the diagram that I have tried to describe, that the given data is of which category, of dog or cat. It is binary classification actually. The data is actually of which it may be dog or not dog, or it will be cat or not cat. So now, but how can you fit or make your model to work or train from this data? So only linear line is not possible. Only regression, simple regression is not possible. So how could you perform this? What is the solution? The solution is to create, like in whiteboard I have drawn the similar chart I have to draw. Okay, and for that, see what we can do. The sigmoid function is there. Sigmoid function gives you the opportunity to draw your work like this. Okay, it is not a single a straight line, but it is either 1 or 0, but not completely 0. See, at minus 10 it is 0, at minus 5 it is 0, at some minus 4 or minus 4.5 it is 0. But after that, between point minus 5 to 0, between this duration, between this distance minus 5 to 0, it will be something point 1, point 2, point 3, point 5 till this point. Okay. Now from 0 to 5 it will be 0.5, 0.6, 0.7, something different, but not 1. See, this is not completely 1 here. So between 0 to 5 it is not 1, but 5 to 10 it is 1. So sigmoid function, this function feature is like it is 0 from negative values, from 0 to negative values it is 0. For positive values from 0 to 10 or more than 10 it will be 1. Okay, so this gives the nature to fulfill our desire, and this is 1 upon 1 plus e to power x. Here we have to take y, because y is a prediction, y is the result. In our case, each and every time x is taken, what it is taken as an input, and y is taken as an output. So we will write here y, 1 upon 1 plus e to power minus y. Okay, and this formula is for this behavior, from 1 slope, then 0. Okay, this is not labeled function. Actually the step function, near about the step function, like if you see, if it comes not giving some fractional values, but between 5 minus 5 to 0, if it was 0, like this, from here to here, and from 0 to 10, if it was 1, then it will be a step function. But it is currently, it is what, it is sigmoid function, and we have to use. So put this y equal to some this. Okay, and we will find this formula p. Okay, okay, we will see this, how it was, how will we get this result. Okay, but it's some logarithmic, because it's exponential, and we will convert it into like p equal to something, right? P equal to this formula, p equal to this, and at the place of x write y. Okay, p equal to 1 upon 1 plus e to power minus y, and find y. You will get this. Okay, p is what, p equal to this sigmoid function, p equal to this function, and x is what, you have to replace x by y. Okay, y is your result, and then convert. You will take log, and then find this log will you will get. So y will be this. We will see how, where it will be used, but the concept is very clear. You are not going to draw a line this time. You are not using to fit a single line. Okay, you are going to what, you are going to draw this sigmoid, this nature, in your classification. Whether it is for binary, you have to take exact 1 or 0, but multi classification, what you have to do, you have to take this nature. Between minus point minus 5 to 0, you can categorize 1, point 2, point 3, point 4, point 5. So it's a very easy to see. Yes, we can easily take 5 classes, and from 0 to 5, point 0.6, point 0.7, point 0.8, point 0.9, and 1. So next 5 classes will be there. So similarly, we can categorize, we can make more classes. So it is actually based on the nature of this function. So we will use this sigmoid function in classification. Okay. Again repeating, we will use any one of them. Okay, any one of these logistic K, NN, or support vector, or decision, or random. But what is the main problem? We have to do this nature. We have to make machine to learn this nature, and we will follow. We will use, because of this, because we want categorize this. So something is with this category or not, and for that this nature is required, and sigmoid gives this facility. So we will use this sigmoid, and somehow this p, we can use any letter p or something else. Okay, So it is generally classification. Now I will show you the practical part of this. And before that, if you have any query, write in chat box. If you have any problem, we have discussed what? We have discussed supervised, unsupervised, discussed the classification, binary
Yes,
classification and multi-classification. So all is clear?
yes, sir. Level of classification.
Okay, good. So try to think, you take your pen and paper, and if you have a separate computer or system, then try to code this, okay? Because it will give you the you know, practical presence. Yes, you are coding. Now, there is code. Classification. What is this? Okay. It's not showing. Timeline. Wait 1 minute. No, the picture is not. It is showing where it is. Good. Clear. Yes, you can see this classification sheet, Jupyter sheet. Are you able to see this?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Very good. Now, see, it may there are some possibilities. Take your screen pic or a screenshot, or write all these lines. But actually, some of these lines are already uh, given into the last lecture, described into last lecture. Just change this name. We have we will use for this classification. Okay, last time we have taken what? Data salary, I think. It was data salary.csv. Okay,
Yes,
so it was
Yes,
already
sir.
there. Data importing was there. What you have to do different? You have to change this name. You have to download social network ads.csv from your social site. It is very easy to download. Okay, what will be there? I will show you this. This is a. Are you able to see this social network ads.csv?
Yes,
Yes,
sir.
sir.
Good. See, there is user ID, and another column is, if you open the seed CSV file in Excel, you will see separate columns. So first column is user ID, another second column is gender column, next is age column, and these are the titles, and estimated salary and purchased. Okay, so how many columns are there? One, two, three, four, five. Five columns are there, and user ID 1562, something like these. These are the you can see the number of entries are there, and in gender you can see male, female. Like this is the gender column. In age 19, 35, 26, 27, 19, 27. See, before without discussing the data, without discussing the data part, you cannot create anything. You cannot work with the machine learning, or I can say in any domain you cannot work. Okay, so it is very essential to discuss or to understand the data or the input you are going to take, of which type and what is the characteristic. So here in this data sheet you can see 5 columns, 5 names, 5 user ID, gender, age, estimated salary, and purchased is there. And in estimated salary, you can see this is not in not in two places. It is 1, 2, 3, 4, 5,000 and 10,000 and lakh something. Okay, and purchased is 0 or 1. So you can easily see only in purchase section, in purchased column, only 0 or 1 you can find. Only 0 and 1. Only 0 and 1. Okay, so what I want to show you through this sheet, this data sheet, I want to clear you this. I want to clear the picture of this data that yes, the input I have taken of which type here, user ID, male, female, their age, their estimated salary, and whether they purchased or not. What? Suppose some social network sign there is some option to purchase something. Suppose one company want to say some what what you want to purchase. Take anything you would want to purchase, but for the same throughout the model. So I want to purchase a car. Okay. So all the data is from user ID to estimated salary is given here. Okay. Now purchase is the result. So X is what? X is through user ID to estimated salary is X. This is your input. And what will be your output? You have purchased or not. So some new car or new edition of car is coming and you want to purchase. So based on the age, their user ID is not sufficient to, but your age and the estimated salary is playing major role. So if you are 35 and your estimated salary is something this, okay, if your age is 26, your estimated salary is 43,000, and your estimated, you are female and your estimated age is 27, age is 27 and your estimated salary is 57,000. So based on this data, uh, this is result that a car is purchased or not. Suppose in this case, age is 32 and the salary is 1,50,000 and she purchased a car. Okay, so this is data about that. So you can feel or you can touch, make sense that what you want to purchase. Okay, whether you are going to purchase yes or no. So only 0 or 1. That means your decision is only binary. So it's a binary classification. Okay, it is not a partial. Yes, I am going to take red color car or green color car or something. No. Okay. So it is only you are either going to purchase or not. So yes or no, 0 or 1. So binary class. So what you are going to perform? You are going to perform classification. Okay. This somebody is purchasing a car. So it is in the section. Yes, he has car, she has car. So he is car wala. Okay. So like this, सचिन के इतने रन बन गए या फिर किसी हिटर के नंबर ऑफ रन आर नाउ कंप्लीटेड सो आफ्टर 5,000 run or something run or number of wickets he will be in this club. Okay, so he will get a cap, he will be in this club. So this is a classification. तो ये हमारा डेटा है. Now what we have to perform based on this data, we are going to perform classification. So data is imported from this file. So you have to change, and here you have also changed the value. Last time you, I think -1 is taken. Okay, your input is X, but -1 is taken because there was 2 columns. So -1 means what? Except last column. Except in this case, what will be if you write here -1? Okay, right here -1. What this means? This means you are except this purchase, all the columns will be in X. Except this last 0, 1 column, all the columns will be in X. But you have to take what? You have to consider, sorry, you have to consider mainly age and estimated salary. Okay, you are young, so you want to take purchase a car. You have age more than 50. You are not interested in a car. So based on the age, if means this is the feature. Actually, these are features. If you are male and female, this also plays a role. But we are considering mainly these two, age and estimated salary. Okay, so we have taken 2, 3. Second column and third column. See, started from here. 0, 1, 2, 3, 4. So 2 and 3 is what? Age and estimated salary. Clear? From 0, 1, 2, 3, 4. So 2, 3 is taken as X as input and 4 as a output. So output is a 4, 4 and 2 and 3 column taken as a input. Okay. So run this and this. Next is what? We have performed splitting. So it is similar to that. Nothing is, I think, extra and different. Only it may be that yes, it is capital and something. So whatever the variable name you want to take, you can put. You can take that name. Okay. So it is similar to that, the previous one. If any question or query at this point, you can, ask. If you are new in this class, then it will be, have some problem to understand. But if you have done 2 or 3 before previous classes, then it will be very easy because we have performed this all. This already we have performed 1, 2, importing, then splitting. Yes, this is new. Okay, this is new. Till this point, this importing, this library import, we have import what? NumPy. Okay, this pandas for exporting, importing, and this for mathematical, and for plotting visualization we have third library myplotlib.pyplot. Okay, so 3 libraries we have imported, and then data sheets as we have imported. Then we have performed splitting, means if you have 100 entries, then 0.25 entries will be taken for testing purpose. Only 75 entries will be considered as training. So your model will be trained on only 75 entries if you have 100 entries. Okay. So we'll see how many entries. It will depend the number of entries in the field in this file. Okay. So splitting is done. Now feature scaling. What is feature scaling? As I already described, age is 19 and estimated salary is not 19, it is 19,000. Age is 35 and the estimated salary is 20,000. Okay. So if we see, there is a big difference between the age column and estimated salary. Okay, so if we want to scale this at one platform, at one level, so we have to scale down or scale up. Means either scale up age or scale down to estimated salary so that these can be equalized. Make the scaling say at the similar level. Okay, so for this labeling purpose, for making the both the columns to similar level, what we are going to do, because this is 90,000, this 43,000, rather than this we see 26 only. Okay, so if we see at 2 points, 19 age 19,000 salary, 32 age and 1,50,000 salary, so there is a big difference. So it may give no some difficulty to machine to learn. So it is very, I think, easy to scale at one level. Okay, so we are scaling this by what? By this code. Okay, so you can see and learn from scale and pre-process import standard scalar. If this is written into capital, this first letter is written into capital, this will be class. Otherwise, like this train and test, it is started from small, so it is function. So we have used function here and it is class. So a standard scalar class. Okay, so from this library pre-processing, we have imported this class And for this class, we have created a what object SC. The object is created. For first year students, it will be just tough. What is class? What is object? But for time being, learn it, remember. Okay, that yes, there are class is a bunch of object, it's a collection of object or collection of items, where object is what object refers to the instant or any member. If you have number of items in a at one place, that place is class. Okay, at one time one item is object. So we have to create an object for that class SC, and this object transforms X train data, because we are going to what? We are going to scaling two columns, because we have divided X and Y into training and testing parts. So training part and testing part we are going to transform for the scaling purpose. Okay, here we can see both are going to transform, but fit transform and transform. So for test purpose, for test data, it is only transformation. While we can easily see for training purpose, it is transform with fitting. Fit means what? It gives training. It works so that training will be easily performed. So we perform transformation. We have to scale in transformation. See, it is already uh, there in libraries, and rotation, then translation, scaling, sharing, number of transformation you have already studied. In interlevel you are aware with this. Translation is what, rotation is what, scaling is what, sharing is what. Okay, in computer graphics, some from I think second, third year, fourth year you study. If you study this subject, computer graphics, you are well aware of the transformation. So we are performing transformation but with the fitting for the training purpose. Okay, so it should be very clear. For training you have to use fit transform, and these are the what, these are the function which is in method in standard library. Transformation is within what, this library, this is class, sorry, standard class. So for this object, you have performed fit transformation, and for this X text, transformation is performed. After performing this, what will be there? The feature is scaled. Feature is what? Age is your feature, estimated salary is your feature, and it is scaled. Scaled means both will be placed at the similar level. So their level of study is similar. So this is also a pre-processing part. You can take as a template. That means you use for each and every data at the similar. From the next for the next, whenever you need feature scaling like this, you have to change the difference, big difference, 19,019 and it is 1 lakh 50. So if you want to make this scaling, you have to use the similar code repeatedly. Okay, like this, importing and splitting and feature scaling. So you can use this as a template. Each and every time use this as a template. So feature scaling is done. Whether we have done is splitting, yes, splitting and see, start from starting point. I think take a minute or few seconds as well. Clear all the outputs. Yes, starting from first run this, it is executed. No, yes, executed, then executed, third splitting. Now after splitting, feature scaling is done. So pre-processing, first, second, three, third, fourth. So these are each and every time you will use. Okay. Now, after this, what we have discussed, after pre-processing, what you have to do? You have to train your model. So first, from library model, linear model, you have to take what? Logistic regression. So there are models in sklearn. In sklearn, what is there? If you see, last time, what we have done? From linear model, we have taken linear regression. Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
Good. Now this time, we are go okay, thank you. This time what we are doing, we are performing classification, and for that we have seen the concept of logistic regression. So from this library, what we have, which class we have taken? Logistic regression class we have taken. Last time linear regression class we have taken, and this time logistic regression class we have taken. Okay, and then perform logistic regression. For this class, one object is created, classifier, and fit this, train. And last time we have already discussed, yes, fit method is used to train the model. Okay, train on which data? X train and Y train. The portion which we have taken for training purpose, 75% portion we have taken as a training. So on the training field, we have applied fit method. This fit method will be from logistic regression class. Okay, so classifier object is created for this class, and for this object we have used fit method so that it can train. And by which data? By using the train 75% data that we have taken from salary social network ad. Okay, so run this. This is what? This is going to train. Now this model is run. Now training is done. Okay, and after that, what we have done? We have predicted this given the training, and after training, what we have to do? We have to check. We have to check our result, and for that, what portion we have to consider? We have to take test portion. 25% portion we have taken as a text. Test. So we have taken X test. Sorry. So as a X test is taken as a testing purpose. So 25% of this data, 25% of this data, why is not? Yes, 25% of this. See how many entries are there? 400 entries are there. 401 entries are total, including which? Including this top title. Okay, you can see at first title is there. So total 400 entries are there. So if see 25% means how much? 100 entries. 100 entries. You can check also how many entries are there in np dot size and x test. 200 entries actually. X test. How many entries we have taken? 25. So it is, if you have total, why it is taken 200? It should be 100. And what is, see from here, np size x, how many entries? 800. Okay, there are 800 entries actually. In this social site, total how many entries are there? It is showing only 400. This is showing only 400, but it is getting how many? 800. Why? What is the reason of this? If the file is similar or different, and this only one file is there. Only one file is there. Why X is taking double entries? There is some problem. First, clear all the data. Are you able what I am doing?
Yes, sir.
What I am doing?
You are trying to calculate the value amount of data in X,
Yes, I actually
size of X.
I'm trying to match. See, there are only 400 entries showing in this. Total 400 entries are there. So if we are dividing into 75%, that means 100 entries for the test and 300 entries for training purpose. Now run this and calculate this. 8 entries. Why it is taking 8? This is 400. This is giving X 2 comma. Okay. See, we have taken two features, age and, see, it is very important point to see, very important point. We have taken which columns? Age and estimated salary, expected or estimated salary, I think, estimated salary. So 400 entries for age and 400 entries for estimated salary. So total is 800 if you see. So how many features you have taken as input? 800. If you remove this, only estimated salary will calculate. See, these are only 400. Understand?
Yes, sir.
Yes. If you want to take all the features, based on all the features you want to decide your result, then the increase will be more. 400 something, 3 times 400. If you will take this gender and but in gender you will see only male and female is there, so that's why we have taken age and estimated salary. If we want to calculate, want to check which one male is going to purchase more or female is going to purchase more, if this type of calculation we want to take, then we have definitely take this male and female feature as. Okay, so we have only taken two features, age feature and estimated salary. So 400 entries for age and 400 entries for estimated salary. That's why it is giving 800. Okay, and now you have 800 entries for training, so 25% is 200. Okay, now it is clear.
Yes, sir.
Yes. So for testing purpose, you have 200 entries. And this is the reason you have to perform this feature scaling. You can easily understand that you are taking 800 entries, 400 entries are like age. Age will be within 100 or maybe 120 or not more than that. So age will be like in 2 digits or 3 digits. But your estimated salary in 4 or 5 digits. So you have to scale it in similar label. Okay, that's why you have done feature scaling. Now you have trained your model. Now you have to predict. So 200 entries will be taken as prediction. So for each and every entry, of 200, it will predict. So run this and try. After this, you will get Y prediction. So you will see that uh, some places one means what? This is going to purchase. Yes, purchased. But this is predicted. This is predicted on X test. Okay, this is predicted on X test. What is X test? What is X test? X test. See this. Okay. See this. So after, sorry, what we have to consider? Okay. How many entries are in X test? X test is 200 entries, and you can see in test. In test, if you see age and estimated salary is in this format, 19 and 19,000 or something, 1,002 digits. But you can easily see here that the portion of this age and estimated salary is now converted point something, point something. See, this is feature scaling. Okay, your age is and your salary is scaled at one level. It is what at the same level. You can see 0.5, 1.5, not in thousand, not in two digits. So all the entries, age entries and the estimated salary is scaled. This is done through this feature scaling. Clear? Okay. Now this is your prediction. This is your prediction based on these entries. Now for these X test, what is the actual values? Actual value is Y test. Clear? For X test, there is a Y test that gives you a correct result, but you have predicted Y pred on the X test. Now match this is. See, at this point it is 1, it is also 1, so your prediction is good. But see, at this point actually this is not purchased. This whatever the entry, that entry has not purchased the car. But you can see in prediction, in your prediction, in model, this machine predicted, this machine learning predicted 1. So this is wrong entry, but it is done. So it is correct. This is correct also. If you see at this point, this is correct. This is also correct. If you match, this is also correct. So maybe there are some, it is like this. This at third last. At this place you can see it is 1, at is 0. So your prediction is what? It should be predicted 1, but it is not predicted. Because in reality, it was predicted. It was predicted means it was purchased. Your car, that is, car is purchased, but actually purchased, but in your prediction it is not coming. It is, the result is wrong. This shows 1 wrong. Actually, it is not purchased. Car is not purchased. Here it is purchased. Yes, of course, match with the real one. It is purchased. But to show this place, third, last third, actually car is purchased here through the Y test, original data. But predicted data says that car is not purchased. So some error or some loss is there. Okay. So what we can say, as in the starting of this lecture session, we have already discussed there are 4 types of result. Whether it is correct, you have predicted correct, okay. You have predicted wrong, you have predicted that car is purchased, but actually it was not purchased. Okay, you are predicted wrong, you have predicted 0, that car is not purchased, but actually it was purchased. And last, the car is not purchased, yes, the car is not purchased. So 4 types of result is calculated. Okay, and we can easily see this confusion matrix. This is confusion matrix that gives the 4 options. Run this. We will further, if you will say, see, confusion matrix is a function taken from matrix class. Okay, and apply at what? At real data, Y test, and the predicted test, predicted result. So you have predicted through Y pred, and your actual result should be Y test. So run this and run. So from this matrix, you will see that 65, this says that 65 correct answer is predicted correctly. Listen my wording. 65 correct answer is predicted. So it is given 65 correct answer. And 25 prediction is done wrong, which was wrong. Okay, so it is positive prediction, मतलब ये सही थे और सही पाए, ये कार परचेज नहीं किए 24 लोगों ने, और उसने भी प्रिडिक्ट किया कि 25 लोगों ने नहीं परचेज किया. तो नेगेटिव आंसर, पॉजिटिव करेक्ट एंड नेगेटिव करेक्ट. Okay, now add this 65 and 24, it is correct, and 8 answers are predicted wrong. Okay, and 3 also predicted wrong. That means what? 8 should be predicted. If you count, like here it was 1 but it is 0, it was 0, it should be 1. Similarly, it should be 0 because it is. So if you count from this to this, you will easily find that yes, 8 or 3 will be 1 or 0. That means it should be 1 but it is not 1, and at the other times, maybe 3 times it should be 0 but it is 1. Okay, understand? I am again repeating. Suppose 8 is what? It may be that it should be predict 1 but predicted 0. At the 3 times it should be predicted 1 but predicted, sorry, it should be predicted 0 but predicted 1. तो 0 होना चाहिए था पर उसने 1 प्रिडिक्ट किया, और 1 होना चाहिए था तो उसने 0 प्रिडिक्ट किया. तो रॉन्ग आंसर उसने दिए, जो उसको करना चाहिए था उसने नहीं किया. दैट मीन्स 8 और 3 टाइम्स उसने ऐसा किया कि या तो उससे 0 या उससे 1 प्रिडिक्ट करना था, जो उसने उल्टा किया, नहीं कर पाया. एंड एट दी 65 प्लस 24 टाइम्स उसने सही प्रिडिक्शन किया. दैट मीन्स 65 टाइम्स उसे यस करना था, उसने यस किया. 1 करना था, उसने 1 प्रिडिक्ट किया. 24 टाइम्स उसे 0 प्रिडिक्ट करना था और उसने 0 प्रिडिक्ट किया. तो 0 मतलब नेगेटिव प्रिडिक्ट किया, सही प्रिडिक्ट किया. 1 मतलब पॉजिटिव प्रिडिक्ट करना था, उसने सही प्रिडिक्ट किया. तो 65 प्लस 24 करेक्ट प्रिडिक्शन, एंड 8 प्लस 3 और रॉन्ग प्रिडिक्शन. उसे पॉजिटिव प्रिडिक्ट करना था 8 टाइम्स बट उसने नेगेटिव प्रिडिक्ट किया. उसे 3 टाइम नेगेटिव प्रिडिक्ट करना था, उसने पॉजिटिव प्रिडिक्ट किया. इस तरह से ये प्रिडिक्शन आपका कंफ्यूजन मैट्रिक्स का है. ठीक है, तो दिस इज आल्सो फॉर व्हाट, दिस इज गिविंग the accuracy. You can calculate from this that how much accuracy is this from this model. Okay, so we have done with this logistic. You see, this is the classification part. Okay, so we have done this with the logistic. Now if we see kk nearest neighbor, then what we have to do, we have to replace this. We have to replace this, do like this, disable this, one, two, three. Okay, it will do like this. What do separate? Okay, rather applying this, we should first from sklearn, neighbor library is there. From neighbor library, kneighbor classifier class is imported. From this class, make a object, and for this object train, perform training similar to this. So replace this by this. If you want to use KNN model, KNN classifier, here logistic regression you used. If you want to use what, this kneighbor classifier, I will tell you what is KNN. So K neighbor is what I will explain you. But before that, I am hurry. I am eager to show you the result. Okay. See, this time we have used K and classifier class similar to logistic regression. We have created this object similar for this object for which K neighbor classifier, and fit method is similar. You have to train based on the data. So run this. So now this time your KNN classifier used, and repeat prediction for this classifier KNN, and now this time apply prediction and check the result where it is. This is apply this. Now see, 8 is now replaced by 3. It is reduced. Your accuracy is now higher. It was 3 and it was 8. Now this time it is 3 and 4. So total 7. Before that it was 8 plus 3. That means 11. Now this time how much it is? Only 7. So accuracy is increased because it was 64 plus 29. Before that, sorry. Okay. So accuracy is now increased. So in this case, K neighbor classifier performing well, K neighbor performing well rather than logistic regression. Okay. So till this point, any one of you have any query? Actually, I want to see the chat box. If you have any query, write in chat box. You can write so whatever your query or confusion in chat box. No, I'm audible. Are you getting my question? Actually, I want to know, sir, please brief about NASCOM.
Yes, sir.
That is another. After this session, you will ask what is NASCOM. We know. Don't ask this time. After this class, you can ask this. No, sir. Sir. So all points are clear. You have to just use import class from your library and use. Okay. So it was all about the classification. Not is all about, but it is some section of classification we have done. In classification, what we have done, we have taken logistic regression code and the KNN classifier code only. But for logistic purpose, we have seen, we have studied the concept. Okay, so it is all about the classification today.